recording, right? Right, so we can start. अब yes, कोई नहीं आएगा. Anyway, so आज I'm planning on doing chapter 3 का hopefully सारा का सारा. ठीक. हाँ, I'm planning on doing chapter 3 का hopefully सारा का सारा, except जो सर ने already कर लिया है, क्योंकि सब डिस्कस करने का आई डोंट थिंक टाइम है. एंड बस वही, और कुछ नहीं. हाँ, अगर क्वेश्चंस होगा ना तो लाइक आस्क ओनली रेलेवेंट क्वेश्चंस, ठीक है. मतलब जैसे वो सर के क्लास में भी वी कैन सी कि एक एक क्वेश्चन करने में इतना टाइम लग जाता है. सो टू अवॉइड दैट आस्क ओनली रेलेवेंट क्वेश्चंस. बाकी तो ठीक ही है, कोई दिक्कत नहीं है. Just a sec.
Yash, are you recording the session?
Yes, I am recording it
Okay, okay.
uh, 2 times so that I don't make any mistakes. Okay, I guess now I can start. Make sure is everyone ready. Is it showing that it's recording? I guess it's showing.
Yes.
Okay, let me share my screen. Screen window. Right, it's visible, right? Okay, so let's start. So this is Sundaram chapter 3. We'll start off with question number 1. I am not going to do question number. I'm not going to do question number uh, 11, 12, 13 and 15. 11 and 12 I won't do क्योंकि मेरे को आता नहीं है. 13, 14, no, 13 and 15 I won't do because सर ने करा दिया है. Right? Other than that, I think I'll do every one. If I run out of time, I'll just continue this, and when I upload this, so I don't plan on stretching this out for 2-3 days. So आज जितना होगा होगा, and that will be end. So if हाँ, so the rest I will just record and upload it. तो कोई दिक्कत नहीं है. Just a sec, then I'll start. Right. So the first question is to so question number 1. Uh, to prove or disprove. Okay. So to prove or disprove uh, that if f is continuous, if f is a continuous function on a bounded set D, so f is continuous. So this uh, C1 essentially means it is continuous once. Okay, so continuous once in the sense it is I mean f is continuous, C2 would mean f is continuous, f dash is continuous, C3 would mean f is continuous, f dash is continuous, f double dash is continuous, likewise. Right. So f is continuous on a bounded set, D, then supremum of f of D is finite. Then supremum of f of D is finite. and it has just बस ये बोला है कि it is bounded, not it's not closed. So this set D is not compact. I mean, it could be compact, but it could not be, right? So that is an assumption that we cannot make. So um, that is the thing, and we need to prove or disprove if the supremum of f of d. So what is f of d? F of d is the range set, right? So f of d is range set, and supremum of f of d is basically the supremum of, so this is, so so supremum of range set. So that is what we need to kind of find, and we need to prove or disprove कि ये जो supremum है that is going to be finite. Now if it were finite, uh, I don't know. So how I did it was, I initially thought that this is indeed correct, and I tried to prove it. Then I was not able to do it, and then I could come up with a really easy counter example. So yes, so unfortunately I cannot say कि इसको कैसे करना है. So that's that. So what is the counter example? Counter example, if I guess if you look at it from a fresh mind, you will be able to clearly see कि I just need my domain to be bounded. I just need my domain to be bounded, and the and I need the range set to be kind of unbounded above, right? And that would meet the criteria for a counter example. So a nice function would be just to define f of x as so to define f from, I need a bounded set as an interval, right? So I just take this set. Okay, I just take this set. It is definitely bounded, but it is not closed, right? So this is an open, this is not closed, and but bounded. So boundedness is all we need to R, right? And how I define f of x? I define f of x as just 1 by x, right? So since f of x goes to infinity as x goes to 0, the supremum of kind of f of d is infinite, right? They're infinite, right? So there is no finite supremum. We are not getting any finite supremum. It goes, we can make that as big as possible. So this proves this works as a very simple counter example. Moving on to question 2. Now it has said that suppose D is a set, so D is a subset of Rn, so the domain is a subset of Rn consisting of a finite number of points, right? So D is just a finite number of points, x1, x2, xn, right? Show that any function has a maximum and a minimum on D. So show that any function on D has a max and min, right? So proof. So it has another part. It says ki, is this result implied by Weierstrass theorem? Explain your answer. So there are two ways of arguing that it will always have a max and a min, right? So the one way, the common sense way, is to argue that since the domain is finite, the range is finite, right? So if my domain set D is just x1 to xn, right, then my range set f of D would again be a finite set, right? So f of x1, f of x2, and f of xn, so on, right? So this is a finite set. Now what does that mean? It means, so now you take any finite set, and that set has a maximum or minimum, right? So that so any finite set has a maximum or minimum. So if I have a set 1, 2, 3, 1, 2, 3 has a specific maximum and minimum, 1 being the minimum, 3 being the maximum. So this is a finite set, and this must have a maximum and a minimum. So this is the common sense of way of arguing this. Another more sophisticated way of arguing this would be to show that the Weierstrass theorem is applicable here, right? So that is what we are going to do to show that. So and basically this is what they have meant when they have asked ki is this result implied by the Weierstrass theorem. So that is also something that we can use. So to apply Weierstrass theorem, what do we need? So to Weierstrass theorem basically demands three things: D being compact and F being continuous, right? Right. So first we will show. So D being compact again means two things: boundedness and closedness, right? So bounded and closed. So the domain D should be bounded and closed. It is obviously bounded, right? Like I said, every finite set is bounded, so it is definitely bounded. So for an argument, you can just write ki any finite set, or you can just do this. You can, let's say, define capital M to be the maximum of x1, x2, xn, right? And you can define small m to be the minimum of x1, x2, xn, and then what you will have is for all x in D, x lies between small m to capital M, right? So which proves that this is bounded. So boundedness is not a issue. How do you prove that it is closed? Well, a well known fact is any finite set is closed. How do you argue this? So what does closed means? What does it mean? It means that D has all its limit points, right? So what does that mean? It means that for any converging sequence, right? So if I take a converging sequence, let's say xn, which converges to x star, such that xn belongs to D for all n, x star belongs to D. This is something that we need to show, right? So to show this, we need to first of all take a converging sequence in D, and then we need to show that x star belongs to D. So what are all the converging sequence that are possible out of a finite set, right? So take an example. Let's say. So take an example. Let's say I have a finite set 1, 2, and 3. When I have a converging, suppose I define a sequence in this set which converges, what are my possible sequences? I can define a sequence like 1, 2, 3, 1, 2, 3. But if I am saying that this ultimately converges, it must be, let's say, at some point of time, it must be just a single number, right? Otherwise, I cannot say that this sequence is converging. So it could be. So I have written 1, but it could be 2, 2, 2, 2, 2, or it could be 3, 3, 3, 3, 3, right? In any case, if I am by construction taking a sequence which is converging, and every member of the sequence belongs to this set, then it must ultimately be a constant sequence. Otherwise, I cannot construct a converging sequence, right? So this is the insight that is being used. So, and if it is ultimately a constant sequence, then what would be the limit point of this sequence? It would be just 1, because after a particular cutoff point the sequence is just 1. For this it would be 2, for this it would be 3, and all of them belong to the set, right? So any finite set, so you can argue using this that any finite set is closed. So how do you kind of formally put it? I am not going to write the entire proof. Uh, 1 or 2 lines is that so what you can write is any converging sequence in finite on a finite set must eventually be a constant sequence. Eventually be a constant sequence must eventually be a constant sequence, and hence it is closed, right? So the limit point is closed. I mean, you can write it in more, you can use more math notation, but essentially this is what is being said here. So this proves that the domain is both bounded and closed. How do you say that f is continuous? To show that f is continuous, what do we need to have? We need to have for all sequences xn which converges to x star such that xn belongs to the domain for all n, we must show that f of xn converges to f of x star, right? This is something that we need to show. And again a very similar argument applies here, ki since xn is eventually a constant sequence, right? It is eventually a constant sequence, like we argued here. Any converging sequence in domain must eventually be a constant sequence. F of xn is also eventually a constant sequence, right? So this sequence f of xn is eventually a constant sequence, right? So think what is happening here. यहाँ पर I have whatever sequence, I don't care how the sequence started, but ultimately it is just a single number, right? So if I take the functional value of x at every one of this point, I don't care how the sequence behaved initially, but after some point it is just f of 1, f of 1, f of 1, and so on, right? So this eventually converges to f of x star. If this is my x star, then this eventually converges to f of x star, right? So again, in more mathematical terms, if you want to write it, xn eventually converges, so xn converges to x star implies there exists a natural number or a cutoff point such that for all n greater than or equals to n, xn is basically equals to x star. This is what I mean when I say that xn is a converging is eventually a constant sequence. This implies, so from here we can write, this implies f of xn is equals to f of x star for all n greater than or equals to n. This means that there exists an n such that for all n greater than or equals to n, your f of xn is equals to f of x star, which means f of xn converges to f of x star, hence it is continuous, right? So we have proved that the domain is compact, the function that we are talking about is continuous. Hence, by the Weierstrass theorem also, we can definitely say that there exists a max and a min. So by Weierstrass theorem, there exists max and min of f on D. So this is how you argue this, but there is a simpler way of arguing it कि अगर the set is finite then it must have a maximum and a minimum, but I don't think if asked in exam sir would want this explanation. Jai Ho. We have next question. So if you have questions in front of you, it's better if you read it. The question is, call a function non-decreasing. So a function f which let's say goes from Rn to R. This is a nice question, I guess. Depends on how you call it, how you feel about it. So if x is a non-decreasing function, so f is non-decreasing. It is non-decreasing if for x greater than or equals to y implies f of x is greater than or equals to f of y. Okay, so they have defined non-decreasing function like this. Now the question is, suppose f is non-decreasing, right? So f is non-decreasing but not continuous. It could not be continuous, not necessarily continuous, right? On Rn, and the domain is a subset of Rn which is compact. Right? Now we need to look at two things. Ki if n is equals to 1, f always has a maximum on D, and what about n greater than or equals to 2? If n is greater than or equals to 2, then is there a max and a min, right? So the first part, right? So this is the first part. So we need to show that f has a maximum on D, and I know that f is a non-decreasing function. So intuitively it is also clear, right? Ki agar if I have a, let's say, compact, so this is my compact domain, and on this function I have defined a non-decreasing function like this, then it must have a max, right, at some point of time. And behavior like this, so let's say behavior like this is ruled out because this is not a non-decreasing function. We can definitely see that it is decreasing. So we kind of have a insight ki it should be true, right? So how do you show it? It is really easy to show that. So we are given that, D is compact implies D is bounded and closed, right? So what does it mean when we say that D is bounded? D is bounded implies that there exists M and capital M such that this holds, right? Now instead of so this is what boundedness means, and closed means that uh, closed means that the limit points are included in D. Now we can argue that, so if we take any sequence in D, right? So take any sequence in D. Uh, by construction, uh, take by construction or not by construction, construct a sequence or it's better to just say that let M and capital M be the least upper bounds, sorry, be the greatest lower bound and least upper bound respectively, right? So M is the greatest lower bound, M is the least upper bound. Now since D is closed, we can construct a sequence, I'm just thinking, do we need this argument? I think we don't. So since D is closed, we can directly just say that M comma M will belong to this set D. So okay, so let me just put a red mark here. So I am not 100% sure if I can directly write this or not, or do we need to argue this? But I guess we can directly write this, which is true. So there is a result which goes that if let's say if xn be a sequence and L be its least upper bound on some set D, then the least upper bound belongs to D. So there is a result, you can I guess prove this, and this is what we are using.
Yes, it is true, by the way.
It is true, but what I'm trying to think is कि बस लिखने से होगा कि नहीं. I guess sir would ask some kind of argument to why.
एक्चुअली जब हमने संदीप सर की क्लास करी थी तो उसमें हम अगर अपर बाउंड सेट में ही इंक्लूड हो जाए तो वही मैक्सिमम बन जाता है.
राइट.
तो इसी से हम शो कर सकते हैं जो फंक्शन नॉन डिक्रीजिंग है तो वही मैक्सिमम होगा एट अपर बाउंड.
राइट. सो इट इज ट्रू तो है फॉर श्योर, बट आई एम जस्ट थिंकिंग कि ये जो लिखे हैं दिस नीड्स justification or not. But point being that this is true. If that D is closed, then the maximum, the least upper bound and the greatest lower bounds belong to this D. Now the problem becomes really simple. Now in this particular statement, you just take f of x on all sides. So f of m would be less than or equals to f of x will be less than or equals to f of capital M for all x in D. Right? The inequalities do not reverse because f is a non-decreasing function. Right? So if I have this set f and let's say this is my x1 and this is my x2, where x1 is less than x2, then f of x1 will also be less than or equals to f of x2. Right? So the inequalities do not reverse. So I can do this. And what does that mean? It means that f of m is minimum of f and f of capital M is maximum of f. Right? So this is proved. So the first argument is proved. What about n equals to 2? N equals to 2, there is a problem. There is a problem relating to how you define this. How is this defined for Rn, where n is greater than or equals to 2? How are you defining greater than or equals to, sorry, this, not this. F of x and f of y are just a single number. They are real numbers. The problem lies here. How do you define greater than or equals to for vectors? So, for instance, if I, let's say, if I have a vector 1 2 and the other vector I have 2 1, what is this? Is it greater than or equals to? Is it less than or equals to, or is it equals to? It is definitely not equals to, but it is again also not either of these. So, there is where the problem lies, or therein lies the problem. Let us use nice English. Anyway, so problem udhar hai. How do you define this? And this is something, so Rangarajan defines this. So, let's say if I have a vector, let's say x1, x2 to xn, and if I say that it is greater than or equals to y1, y2, yn, right. So, Rangarajan does it like this, implies, or in general also, that for vectors this is how greater than or equals, this partial order is defined, is each xi should be greater than or equals to each yi, right. So, for component wise, so if every component of this vector is greater than every component of this vector, then I say that it is greater than or equals to that. So, that was the first thing. What is the other thing? Here what is, so let's go all the way back to part A, logic, right. So, I hope if you can remember what was the truth table of implication, right. So, if I have a statement P, if I have a statement Q, then P implies Q. What is the truth table of that, right. So, if P is true, Q is true, this is true. If P is true, this is false, this is false. And if P is, so if P is false, then it doesn't matter if Q is true or false, this is always true, right. And I mean, this is there is a reason why logic is a important thing. Here what is my statement? My statement is, so my statement is P, that if the statement P is x is greater than or equals to y, Q is f of x is greater than or equals to f of y, right. And I am told that P implies Q is true, right. So, I am told that this is true. So, I am looking at these cases, right. So, I am told that this entire statement is true. Now, it means I can definitely consider cases where P is false, or at least where P is not true, right. So, point being to construct an example where this I guess this is antecedent or क्या बोलते हैं. Anyway, so the insight lies in constructing an example where either this is it doesn't hold, or it doesn't, or it isn't true, but the function is increasing and it doesn't have to be continuous, and then we can just construct an example such that there would be no maximum. So, let us do it. So, we can define our domain like this, right. So, we can define our domain as, let us say, x comma minus x, such that and we need to make it bounded, right. We need to make it compact and bounded. So, x comma minus x, we can have this, let us say x comma minus x belongs to R2 such that x lies between 0 and 1, right. So, let's say if this is the, so basically what I am talking about, so let's say if this is the positive x direction, this is positive y direction, or let's say that is positive x direction. So this is positive x direction, positive y direction. So this would be negative y direction, this would be negative x direction. I am talking about all those points where x is negative and y direction is, x is negative, y direction. So basically I am talking about, let's say this point, this area. Let's say this is my negative 1, this is my positive 1. No wait, this is x, so x is negative. I am not talking about, sorry. I am talking about this area, right, where x is positive, y is negative. So I am basically talking about this unit square. So I am defining this to be my domain. Now why did I particularly choose this? Because here any point that you pick, is it true that any point that you pick, let me think for a sec. So here we are talking about points like, let's say 2 comma minus 2 and 3 comma minus 3, right? Right, so pick any 2 points here, any 2 points, let's say 2 comma minus 2 and 3 comma minus 3. So basically I am not talking about this entire thing, I am talking about just this line, right, just this line. So x comma minus x. So I can only have points like 2 comma minus 2, 3 comma minus 3. Now
हर्ष देन यू डिफाइन द, मतलब यू कैन चेंज द लिमिट, क्योंकि x तो 1 से 0 के बीच में आ रहा है, तो हम -2 और 2 नहीं ले सकते ना.
that is also, but for illustration purposes fine. Anyway, so let's take half comma minus half, and let's say 1 by 3 comma 1 by 3, 1 by 3 comma minus 1 by 3, right? Here the thing is, we cannot ever compare these 2 points. So I cannot say that this is greater than or equals to 1 by 3, 1 minus 1 by 3, because this component is bigger than this component, but this component is smaller than this component, is bigger, minus 1 by 2 is, so one is bigger than the other. So I cannot clearly say that this thing is greater than this thing, right? So the statement P is always false for any function that I define here. For any function defined on this particular domain, P is always false, right? So if P is false, so right, so I basically, and the what is asked that if f is non decreasing, then there must exist a maximum. That is my question, right? So that is the question. Now I am just focusing on the part where how I define f to be non decreasing, right? So I just so I am basically focusing on this thing, I am basically focusing on this case where this doesn't hold. If this doesn't hold, then for any function, right, for any function defined on this particular domain, it will be a non decreasing function. It doesn't have to be actually non decreasing function. Any function on this domain is non decreasing function, right, because the overall truth statement, the overall truth value is true. So therein lies the trick, right? So since the premise is false, any conclusion that I draw from it is kind of true. So this is false. Any function that I take it doesn't have to be, just a sec, it doesn't have to be a non-decreasing function. Right, it doesn't have to be a non-decreasing function, but when I combine these two together, the overall statement is that it is a non-decreasing function. So now the problem is easy. So now all we need to do is just think of a problem jiska just think of a function defined on this domain such that the maximum doesn't exist, right? uh, I can do it like this. So I can define f which goes from d to r. F of x is just, let's say again, just 1 by x, right? We can see that f of 0 is just something that is just not in the set. Not in the set means the maximum doesn't exist. So at f of 0 it shoots off to infinity. It doesn't shoot off to infinity. Wait, just a sec. Okay, just a sec. We had to, so it doesn't have to be continuous, right? It doesn't have to be continuous. Wait, this isn't, I guess it is inaccurate, because this saying this won't work, because f of x is not defined at this.
Harsh, you can take any arbitrary function, easily हो जाएगा.
हाँ, but it would be nice to take an example. Also, हर्ष क्यों बुला रहे हो मेरे को?
Sorry, मैं भूल गया. Yash, sorry.
Anyway, which is true. So basically, any arbitrary function here. So the trick. So I kind of, I should not forget it like this, because अगर ऐसे भूल जाए तो I would forget an exam. But I guess if we think about it, we'll be able to find a function such that it doesn't have a maximum on this. So basically, we kind of make it asymptotic. Maybe log. Nah, then log of -1 would be not defined. But yeah, so any function. So basically, take example of any function. So any function that doesn't have a max on D will suffice. Doesn't have to be. So I'm drawing a blank here. I don't know why. So any function would do, because it doesn't have to be necessarily increasing or decreasing, because it is vacuously true. Because since we cannot even compare 2 points, whatever function we define, it is going to be increasing. So you don't have to worry about it being increasing. So any function which doesn't have a max will suffice. And I don't know why, but I'm drawing a blank. But that is how it is done. Anyway, moving on to the next question. अगर बीच में मेरे को something comes to my mind, I'll say, wait, does this compact? Right. Any question number 4 is give an example of a compact set. So give an example of compact set D, which is a subset of Rn, and a continuous function okay, just a second, 2 seconds. Right. So we need to give an example of a compact set D and a continuous function f such that f of D consists of exactly k points, right, where k is greater than or equals to 2. Is it possible if D is also convex, right? So this is one thing. The other thing is it possible D is also convex? Why and why not? So a very simple argument here is you can take D to be, let's say, 1 2 3, right? Now D 1 2 3, it is clearly, so like we argued here, any finite set is closed bounded, hence compact. So this is compact. A function defined on this, so I can just define f of x to be x. This is my function. This defined on D is again continuous. Again we argued that, right? So it meets the criterion that it has this. Now the thing is, the if I say that f of D consists of exactly k points, right? So so let's say this is my domain D, this is the range f of D, right? Now I am saying that f of D consists of exactly this many points. What does that mean? It means that what does it mean? That this can't happen. Right, but something like this can happen, right? Okay, so I guess I can have but then it won't be continuous anyway. So the f of D has exactly k points. Is that satisfied here? Yes, right, because f of D here is also just 1 2 and 3. So it satisfies that it exactly has k points, right? So it exactly has 3 points. If I define my set to be something else, it is other than that. But is it possible that D is also convex? In this case it is not. So this is a question that I had a doubt in. I think I'll have to go to sir again for this. So okay, so that is another thing. I have not, so all the questions that I am doing, I'm not like 100% sure, okay? So there are thoda sa inaccuracies here and there. So sorry about that, but anyway, that's that. So is it possible that D is also convex? Well, no, right? Because this set is not convex. 1 2 3 is not convex, because you can take a convex combination between 1 and 2. So basically any number lying between 1 and 2 doesn't belong to the set D, hence D is not convex. But is it possible to find such an example? That is the question. So in this particular example it is not possible, but is it possible? That is something that I have tried thinking about, but कुछ आया नहीं दिमाग में, because I can define my function to be something like this, right, where let's say all the points point to one thing, all the points map to, let's say, another. So I can have, let's say, this. So here the range set has exactly three things, but the domain doesn't have 3. And then I do this. Now the problem is, if I make, so I have tried thinking about some things. Every time the problem is whenever I try to make this convex, the continuity fails. So that is a problem. So there is some kind of a contradiction, but I'm not able to put it down formally. That is a issue. Is there iska solutions manual mein, is there anything? I don't know. I have not seen the solutions manual yet. But so this is what all I could come up with for this question at least. So if any of you is able to do it, let me know. But the answer is that no, it is not possible to have a convex. How do you prove this formally? I'm still working on it. Sorry. Question number 5. What was question number 5? Question number 5 was if f is a function from r plus to r plus, right? So it's a
Yes.
huh,
When I say domain D is a subset of Rn, तो
right.
उसका मतलब ये नहीं होता कि D के जो points है they are n dimensional vectors, या ये होता है कि उसमें n points हैं.
No, no, it's an n-dimensional vector, right?
Yeah, so you have taken set D to be a set of 1, 2,
Yeah,
3
so I'm
ऐसे.
just assuming. So since they have asked us for an example, right? So I can just, for example, I can just take n to be 1, which is right. I should have mentioned it.
Okay.
So since they have asked for an example, but I guess when you will be trying to argue this, then I don't think we can take n to be 1. Mane, if this is mane, if it is possible that D is compact and f of D has exactly k points, then just showing an example would work. In that case, you can just take n to be 1. But if it is not possible, then you would have to disprove it for every n. Then n taking n equals to 1 won't work, and you have to show it formally, which I have not been able to do. So that is it.
अगर नहीं हुआ पॉसिबल तो व्हाई डू यू हैव टू शो कि हर एक n के लिए, वो तो किसी एक n के लिए से 2 3 तो हो जाएगा ना. तो प्रूव करते हुए हर एक n के लिए शो करेंगे ना, डिस्प्रूव में क्यों करेंगे?
No, because what you're trying to prove, so you're trying to prove that it is not possible, right? So maybe you can say that ठीक है, for n equals to 1 के लिए नहीं हो रहा है, but हो सकता है n equals to 2 के लिए हो जाए, right? So it is saying that every case it is not possible. And is it possible? So here, so basically you need to kind of differentiate between what is a particular case and what is a general case. Here they have asked us for a particular case in the first part of the question. Like give an example of a compact set and a continuous function on that set such that f of D is exactly k points. We gave a particular example, right? And in this particular example, D is not convex. But what if I took a set like this 0 comma 1, right, and I define my f of x such that it is let's say the greatest integer function of x, right? Then f of D has exactly 1 point, or let's say not 0 comma 1, let's say 0 comma 4, right? So then f of D would have exactly k points. K could be anything greater than 2, so it would be exactly, or let's take even a general function, not let's take f, let's define D 0 to k, where k is an integer, okay, and I define f of x to be the greatest integer function, this. Then what is f of D? F of D is just 0, not 0, it will start with 1. It will start from 1. So it will go to 1, 2, and it will go to, let's say, k minus 1, right? Or if I take यहाँ पर k plus 1, then it will go to k. So my domain is, so I was able to find a D domain such that it is compact and f of D which has exactly k points. But where is the problem? Problem is that it is not continuous. This function is not continuous. right? If you plot it, you will see कि ऐसा ऐसा करके उसका graph है. So it is not continuous. But the thing is, we are not sure, right? So maybe there exists some function. So when we are trying to show that okay, it is not possible for any function, any domain, and any n, then you would have to show for all n. That is why it is challenging,
Okay.
at least for me. That is, if anyone of you is able to do it, do send it in the group. Question number 5, fortunately I was able to do. It is a nice, so okay, so question number 5, the idea used in question number 5 is also used in some other question later on. So the idea is very nice and important. So they have asked ki a function f goes from r plus to r plus. So it's a single variable function and defined on the positive real numbers. Sorry, it is not r plus to r plus, it is r plus to r. Sorry. N is continuous, right? And the following conditions hold, that f of 0 is just 1 and as limit x tends to infinity, f of x is 0. I need to show that f has a maximum on r plus. Show that has a max. The other question is, what about min? Right? So let's try to visualize this. So any function, this is f of x, this is x, that direction. I don't have anything, but it's just on positive this, and it is r plus to r. So and it starts from 1. So I know that it starts from 1, and then I don't know how this behaves, right? So it could be like this, whatever. Okay, that was, I don't know why that happened. It could be anything, but the thing is, as I go to infinity, it tapers off to 0, right? So this is let's say a very rough idea of what this function might look like. Now we are asked that to show that whatever be the shape of this function, and this is continuous, by the way, so this is continuous, there are no breaks in it. The thing is, whatever be the shape of this function, I should be able to find a max. Let's say here I am able to find a max. Will I be able to find a min? Always. So in this particular case, I can see that there is a min. But what about, let's say, something like this, where fine, I start off with 1, I go somewhere and then I go to very low and then like this, or right, then also I can find a max and a min, right? So it goes to this, right? So we can see that there should exist a max and a min. There should exist a max and a min, but how do you formalize this argument? So the nice thing here is to use this fact, right? Is to use this fact that as x tends to infinity, f of x is 0, right? So what does that mean? So solution, limit x tends to infinity, f of x 0 basically means that this particular sequence of x it converges to 0. That implies that there exists an x in real numbers, right. So, in R plus such that, or let us say there exists a k, let us say, such that for all x that is greater than k, mod of f of x minus 0 is less than epsilon. Achha, for all epsilon. Okay, so I should have added it ekdam pehle, right. So, for all epsilon greater than 0, there exists a case such that my functional value, so my function strictly lies between this, right, and I can choose whatever epsilon I want, right. Now, if I choose an epsilon which is, let us say, equals to half, then I can say कि there exists, let us say, a k half which is a real number, positive real number, such that my f of x strictly lies between positive half and negative half, right. Let us say I am talking about this particular point. Let us say I am talking about this particular point. Let us say this is my k half. Beyond this, let us say this is positive half, this is negative 1 by 2, right, and I can see that beyond this it is in this plus minus half wala band, right, right. Now, basically यहाँ पर what was so we would be able to argue that a max and a min would definitely exist had the domain been compact. Now, what is the domain? Domain is R plus. R plus is closed, we know. So, if I take a sequence of positive numbers, it will always converge to a positive real number. So, it is closed. The problem lies in unboundedness. It is not bounded, right. Right, it is not bounded. So, if I am able to get rid of that problem, if I am able to argue that it is, or if I am able to somehow change my domain to make it bounded, will I be able to find a max? And that is true. So, that is exactly what we are doing here. So, that was so that is what we did when we took epsilon. So, the moment I took epsilon equals to 2, I got a cutoff point k 1 by 2, right, and then I am only considering f. So, consider f on this interval 0 to k 1 by 2, right. So, consider this only in this interval. Since after this interval the value of f of x can be at most, so in this interval the value of f of x is at most f of half, right, which is less than f of 0, because we know that f of 0 is 1. So, we know that beyond this point, at least for maximum, this portion does not matter for us, right, because I know that इस particular band में जो भी maximum value वो ले सकता है वो है half, and I already know that f of 0 is more than half, and that is the reason why I took half. You can take any number which is less than 1, any number which is less than 1 would work, any positive number, right. So, we could have taken 1 by 3, 1 by 4, whatever. The point is that anything in this region is less than half. And what about this set, earlier it was not bounded, but if I consider only this set, then it is bounded. And it is not only bounded, it is bounded, it is closed. The function defined here is a continuous function, right? So basically we had a bigger continuous function, we are just truncating it. So on this f, all the conditions of the Weierstrass theorem is applicable. Hence, there exists a max and a min of f on this interval 0 comma k 1 by 2, right. Let's call the max let's say capital N. Okay. So in this interval I know that there exists a maximum of f and I am calling that m. Now consider f max. Now this f max is basically the maximum of entire function, not just this truncated thing, right. And I know for sure, so basically okay, we don't even have to consider this herein, yahin par the problem is done, right. So I know that each and every one of the functional values here is less than 1 and I have a maximum on this interval. Now that maximum can be equals to 1 or it can be something more than 1, because Weierstrass gives us the global max, right. So let's say if the function was, let's say, something like this, right, then the maximum would have been 1, no issues. Point being, whatever the case is, that m is always greater than or equals to 1. It is always greater than or equals to 1. Either it is more than 1 or it is equals to 1. And beyond this point, my functional value is strictly half. So it is definitely greater than half, obviously. What does that mean? M is the global max of f. Right? So this way we can argue that there exists a maximum of this function. So this portion is this we have done. What about a min? Well, ये blue line में we can see a minimum exists, यहाँ पर भी we can see a minimum exists, but these are special cases. We can again think of this red example, right? So this red example is just it is just like 1 by x kind of a thing. इसका we can see that there exists no minimum. It gets very very close to, so जितना दूर जाओगे उतना 0 के करीब जाते जाओगे. So there is no minimum. So for minimum we can just give this example, right? So no, minimum doesn't always exist. No, minimum doesn't always exist. Why? So we can give an example. We can take f of x to be 1 by x, and we can
Harsh, you can take, oh sorry, Yash, you can take 1 upon 1 plus x.
Yeah, we can take 1 upon 1, because then it is, that is what I was thinking, 0 पे defined नहीं है. So we can take 1 upon 1 plus x. This is ensure that it is defined at 0 and it will go off to infinity, there is no min. So that, but this idea that we used, कि after some particular point it is strictly in some band, it is also used in some other question. I am not sure कहाँ पर use किया था, but use किया था. Right. So what is the next question. So question number 6. Question number 6 you can if you use a result it is small. So यहाँ पर बोला है कि C is compact. So C is a compact set. It is a compact subset of R. G is a function from C to R, and F is a function from R to R. And this is continuous. Is a continuous. Does the composition f of g have a max? So that is the question. Does f of g has a max? Right. Is g continuous? Right. So I guess both of them are continuous. Right, because it has said suppose g and f be continuous function, be a continuous function. Let g be and okay, if both, okay, so I did not see this earlier. So there can be two possible cases. One, if both of them are continuous, and the other is one of them is not continuous, because the way that they have written the question, it is weird. So they have said that let g from C to R and f R to R be a continuous function. So if this is continuous function, I am not really sure about this. Okay, let's assume ki this is not continuous. That would be the general thing. So does this have a max? Now we can define h as f of g, right? So h of x is just h of x is just f of g of x, right? And I know that f is a continuous function. If this is a continuous function, it should be, right? So even if g is not a continuous function, g only gives me an input which goes into f, right? And the output always comes from f. So this is a continuous function, and I guess you would have to show that formally. I am not doing that here, because time lag jayega. But this is a continuous function, and that is entirely, so again I am just giving a pointer here, ki that is the entire question, ki we need to show that this is a continuous function. We need to argue that, and if you are able to argue this, we can show that it will have a max, right? So, and it is, I guess it is not that difficult to show. We can just take any sequence, take any I mean, let's take any sequence in C, take any converging sequence, let's say C of n in C, such that Cn converges to, let's say, C star. Now C is compact, so C star belongs to C, right? Now consider the sequence, the sequence f of Cn. F of Cn will always belong to real numbers, right? So f of Cn, sorry, not f of Cn, g of Cn. So everything I am taking g. Now the thing is, since g is not continuous, we can't say, that g of Cn will basically converge to g of C. This is something that we can't say, because we don't know if g is a continuous function or not. But we can say, what we can say is, whatever g is, g of Cn is always a real number, right? It is always a real number. It won't suddenly output a complex number out of nowhere. So we can have g to be not continuous, but whatever be the output of g, it is always a real number. So whatever gn that I take, the output is a real number, and then we consider this sequence f of g of cn, and this converges to, so let's to simplify things, let's call this zn, right? Now take the sequence f of zn. Okay, right? So okay, acha, this is the problem, right? Not as easy as I thought initially. So to show that, but f is continuous, right? So we need to show that g of n is continuous. So we basically need some limit point here. But अगर यहाँ का ये limit point ही exist नहीं करेगा, then how do you argue that this converges somewhere? That is the question. Anyway, just a sec, let me look at the solution once. Just a sec. Has anyone of you done this question?
यश मैंने जी कंटिन्यूस लेके सॉल्व करा था.
So अगर g continuous है तो this is ठीक है, because let's say if g is continuous, then I can say that g of, so I will be able to say this, and
then
then
f of g भी कंटिन्यूस हो जाएगा, फिर उस पे थ्योरम लग जाएगी वही.
तो वो ठीक है, but यहाँ पर what they have done, so this is एक सेकंड, let's see कि solution में वो लोग क्या किया. Even in the solution if they just assume continuity of g, then तो कोई दिक्कत नहीं है, हम भी वही कर देंगे. But this is indeed, this is the thing, right? लगता है कि सब हो गया, but then you do it again and then फिर दिक्कत आता है. This is right. Continuity is invariant under composition, that is composition of continuous function is still continuous. So they have assumed that g is also continuous. So if you assume this to be continuous, then so it is trivial, then it follows, because if this is continuous, then this, यहाँ पर we can take f of g of cn, it will converge to f of g of c, hence because of continuity of this, right? And therefore h is continuous. Hence by Weierstrass theorem this exists, but I guess we'll have to think ki what if this is not continuous. If this is not continuous, will this still hold? But as far as this particular question is concerned, this is the answer, right? So do not, or kind of, this is something to think about. Anyway, question number 7. Question number 7, I was not able to do it initially, but I guess they have provided a counter example in the solution. So so all of you have the solutions, right? My solution manual. If no, then ping in the group.
Yes.
Ping कर देना ग्रुप में, अगर किसी के पास नहीं है तो I'll just send it in the group. तो हो गई, काफ़ी लोगों के पास होगा. तो they have given a counter example, so there is nothing to really explain. Just look at the counter example, it works. The next thing is use the Weierstrass theorem to show that the expenditure minimization, as long as utility function is right. So question number 8, I'm not writing the question. The thing is, we just need to show that expenditure minimization problem का solution exist करता है, so long as, so okay, so although sir has done this, I just want to do an alternative explanation कि क्यों exist करेगा, right? So the problem is to minimize the expenditure. Now what is expenditure? It is just x times px plus y times py, right? Subject to utility of x and y being greater than or equals to some fixed u bar. What is it that I am given? We are given that u is continuous and the price vector dominates the zero vector. So each of the price is positive, right? We need to show that the solution, the optimum exists. So here the problem is with boundedness, right? Since the objective function is a linear function, this is obviously continuous, right? You take any xn sequence, any yn sequence, it's xn converges to x, yn converges to y, then this entire thing will converge to xpx plus ypy. So it is continuous. The domain is closed, right? So the domain is closed. So if you want to argue it, you can argue it. It is so basically to say that this is closed is basically we would have to take for all kind of xn comma yn such that u of xn comma yn is greater than or equals to u bar, xn converges to x, yn converges to y, then limit of xn yn, I don't think of u of xn, u of xn yn, this will converge to, let's say, some u star which is which will again be greater than or equals to u bar. Why? Because of continuity of f, continuity of u. So that is why we need those assumptions. That is why we need those assumptions. It is the u needs to be continuous. If it is not continuous, then it might not hold. So basically, this will converge to u of x star y star. Sorry, so u of x. Just write it thick. So this will converge to u of x comma y, which will again be greater than or equals to u bar because of continuity of u. Right. So you need continuity to show this result. This is a real analysis result. नहीं जाना इसके अंदर अभी. But this is something that is used. So that is why if you take this assumption away, this might break down. What is the significance of this being greater than 0? That we will see. Right now, so what is the problem? The problem is कि so this is continuous. So continuity is ठीक है. It is closed, right? That is also ठीक है. It is closed because of this. We just use this result. It is not bounded. It is not bounded. So the way sir was did is to take sequence and then show that there is a subsequence which is bounded, and that is all we need, which is nice. But there is another way of doing it, जैसा book में दिया हुआ है. And for me it was, at least exam time में doing this would be much easier for me, is to fix any, so take any x, so take any, so first of all assume that, there exists x and y in real numbers, right, such that u of xy is greater than or or equals to u bar, or in some other way the domain is not empty, right? Your domain empty रहेगा तो फिर then there is nothing to do, right? So assume that the domain is non-empty. then take any x bar comma y bar such that u of x bar comma y bar is greater than or equals to u bar, right. So, there exists some bundle x bar y bar. So, there exists some bundle x bar y bar which is feasible, ठीक है, which is feasible or which is kind of in my domain. Then define, so what is the expenditure corresponding to this particular bundle? So, E bar, right, I can define E bar to be my x bar px plus y bar py, right. So, if I consume this bundle, I need to incur this much of expenditure, right. Now, think of a case so the consumer, right, so the consumer will never buy a bundle or consume a bundle x comma y such that x is greater than E bar by P of x. Why? Why won't the consumer ever buy a bundle xy such that x is greater than this? Because think about it, if you buy a bundle like this, or let us say add a 10 here, doesn't really matter. We need to add something here, but anyway. So, why will the consumer never buy a bundle xy such that x is greater than 10 times E bar by Px? Because suppose that they do. So, let us say if you are able to buy a bundle xy such that x is greater than this quantity, what would be your expenditure? Your expenditure would be 10 times E bar by Px times Px, which is just 10 times E bar. So, no matter plus whatever y costs, right. So, plus whatever y costs. So, this expenditure is always greater than or equals to 10 E bar if you buy a bundle such that this happens. Then think about it, why will you ever buy this? Because to buy this bundle you are spending 10 E bar amount, but by construction I have a bundle x bar y bar such that the utility is greater than u bar. So, that is one requirement and it costs less. Instead of 10 E bar it costs only E bar. Why will you ever buy this? You will never buy this. A rational individual will never buy any bundle such that it is greater than 10 E bar by Px. You can use the any number here, 2, 3, 10, 15, 20, whatever, it would work. But the logic should be clear. The logic is that the consumer will never buy because there exists a cheaper bundle which is feasible. Therefore, x will always be greater than, or just for the sake of making the new domain compact, we just add this here. So, he will never buy a, or they will never buy a bundle which is greater than or equals to this quantity. Similarly, we can argue it would never buy a bundle which is greater than this. So, what is effectively the domain? So, the domain effectively becomes or x is basically less, or x comma y, this vector is always less than or equals to 10 E bar by Px, 10 E bar by Py right? So what is my domain? Domain is just all x y in R2 such that u of x y is greater than or equals to u bar, x is less than or equals to 10 e bar by px, y is less than or equals to 10 e bar by px, and that's it. So this is my domain. So my new maximization problem is to minimize expenditure such that x comma y belongs to D, where D is compact, right? Why is this D compact? Because it's a nice subset of R2, right? So we already know that it is compact. It is bounded also. We just made it bounded, right? We made it bounded. It is closed. It is closed and it is bounded, right? Again, why is this closed? Because again, if I take any sequence of x and y n such that x is less than or equals to this, y is less than or equals to this, then x converges to x star, suppose, then x star will also be less than this, and that is again a result in real analysis we used earlier, or we proved earlier in real analysis class. So this is closed and bounded, hence a max and a min exist. So this is the logic that the book has used. I find this logic to be much shorter with respect to, well, exam time के लिए I guess this is better. If you like सर का solution, it is fine. ठीक है. And earlier I was talking about the significance of this, why the P must be strictly positive. P must be strictly positive, that means P of x should be positive, this should be positive, is because of this fact, right? We are dividing by Px because Px is not equals to 0 or Ps is strictly positive. यहाँ पर भी we can do this because Ps is strictly positive, and this is based on the assumption that price vector dominates the 0 vector, component wise dominates the 0 vector. So if we relax any one of these assumptions, a solution might not exist. If u is not continuous, then this might not be, our domain might not be closed, and if we relax this assumption, then we might not be able to make our domain bounded, hence both of them are required. That was question number 8. Question number 9, did I do question number 9? I don't think so, or did I? So question number 9, they have said ki consider the profit maximization problem. For simplicity, assume that the inverse demand facing the constant. Okay, so the problem is to maximize P times y minus W times x. P is the price of output. It's pretty self-explanatory. This is just cost of input. So your basic profit maximization. The inverse demand function is constant. So basically, P is a function of y, right? So this is my inverse demand function, right? So this is this. What else? That is constant. So basically, this is, let's say, some particular constant a. So my maximization thing is maximize a times y minus w times x, right? And this a is greater than 0 for all y, fine. Assume also that the technology G is continuous on Rn. So the technology, so y, so this is G of x. So I can write y to y as g of x, right? So g is basically my production function minus w times x. G is continuous. My w is greater than 0. Are these assumptions sufficient to guarantee the existence of a solution for the profit maximization problem? Why or why not? Right. I did not do this. I have done it, but now I notice that I have done it incorrectly. Nice. So, what are the things that are needed here? So, x belongs to Rn plus, right? So, this is definitely continuous. So, this is continuous. Domain is closed, right? So, this is my domain. Rn plus n ऊपर जाता है. This is closed. We need to argue that this is also bounded. Huh. Acha, what if my production function is increasing returns to scale, or if it is constant returns to scale? If it is increasing returns to scale, my output goes up more than the input. Okay, so it is not bounded above, right? We somehow need to make this bounded above, नहीं तो maximum नहीं exist करेगा. So again we can, I guess, construct, but there is no thing. Okay, let me look at the solution. What they done?
यश
हाँ.
दे टेकन लाइक एक्स स्टार जहाँ पे प्रॉफिट 0 हो रहा है, तो जो मोनोपोलिस्ट है वो कभी भी ऐसा एक्स स्टार नहीं लेगा जहाँ पे
नहीं,
प्रॉफिट
this is
0 हो
not
जाएगा.
monopolist वाला सर. Monopolist is I guess 13 वाला. This is
अच्छा,
like number
मतलब
9.
जो भी हम प्रॉफिट मैक्सिमाइज कर रहे हैं तो हम कभी भी वो एक्स स्टार नहीं लेंगे जहाँ पे प्रॉफिट 0 हो जाएगा.
Right. So
तो एक्स को तो ग्रेटर देन 0 हो, मतलब ग्रेटर देन 0 होना ही है, बट लेस देन एक्स स्टार पे हम करेंगे तो फिर वो बाउंड हो जाएगा उससे.
right. Profit is negative, so they won't operate in a for a x such that the profit is, so when is a times g of x minus w times x is less than or equals to 0. It is less than or equals to 0 when a times g of x is less than or equals to wx. So let us consider a set D x belongs to Rn such that profit of x is greater than 0 or equals to 0. So then फिर वही problem आ जाता है ना कि how do you show that this is bounded and compact? This is closed definitely, but this is because this will put a lower bound, right? So let's say this would put a lower bound, but if g is increasing, I don't get a solution again.
आई थिंक इसने लोअर नहीं अपर बाउंड पुट किया है बिकॉज वी हैव लोअर बाउंड कि तुम कुछ प्रोड्यूस ही ना करो, एंड इस वाली कंडीशन से अपर बाउंड आएगा जहाँ पे तुम्हारा प्रॉफिट विल बी 0. दैट एक्स स्टार जहाँ पे प्रॉफिट इज 0 विल बी आवर अपर बाउंड फॉर एक्स.
So suppose my so that is the thing, right? So such an x is not guaranteed for this general g of x, right? Because suppose the g of x Okay, suppose g dash of x is greater than, first of all, I don't think we can just differentiate this, assuming x is, let's say, single dimension, x belongs to R1, just for sake of simplicity. This is this. So basically the problem that I have with your argument is that suppose 5 यूनिट प्रोड्यूस करने से the profit is 0, right? Then I can just produce 6 units to have a non-zero profit. Now that is not always doable, because I have kind of diminishing returns. So I guess we need to imply the restriction of diminishing returns so that this becomes continuous. Right. So if the production function, if g of x exhibits diminishing returns to factor input, then there exists a max, right? So this is the condition that we need to impose, and iske baad whatever that you guys just told me ki the profit must be strictly greater than 0, that is that will work. Right. Nice. This is nice, right? Because then suppose I have an x bar such that my a times g of x minus wx is less than or equals to, or if it is equals to 0, suppose, right? Then if I increase, so if I halka sa increase my x, my profit will fall, because everything is constant but it is decreasing returns to scale, decreasing returns to factor input. So diminishing productivity की वजह से my profit will further fall. Therefore it is right, this makes sense, but I guess we would still have to work out the formality of everything, but this is the nice. This is how you would do it, right? Correct. So I guess you need to take, so this is the answer, we need to impose diminishing returns. That is also a reason why हम लोग जब profit maximization करते हैं तो production function को diminishing returns बोलता है, because think about it, अगर increasing returns हुआ factor में, तो फिर even if you do let's say मैंने first order condition second order condition भी करने से उसको कोई maximum ही नहीं मिलेगा, because you need g double dash to be negative.
Of course, and well behaved production function में diminishing returns to scale ही होता है, तो ये हम कर सकते हैं.
That is the answer, I guess. And this is the reason why I don't trust this solution manual entirely, क्योंकि यहाँ पर बस सीधा लिख दिया कि solution is not guaranteed. So, and that was not the question. The question was what condition would guarantee an existence of solution. So that was the question. Okay, question number 10. Right, so question number 10 is कि this set f of w comma p such that x comma l belongs to R n plus 1 all positive, such that p dot x is less than or equals to w h minus l and l less than or equals to h, is compact. थोड़ा बहुत context दिया हुआ है question में, you guys can take a look. Is compact if and only if p vector dominates 0. So this is this where quick interpretation, this is wage, this is leisure, this is number of hours in a day, or total number of hours. Right. This is cost of leisure. No, what P kya tha? P was something I forgot. P was basically cost of food, whatever. इंसान काम करेगा तो कुछ खाएगा, तो जो खाएगा उसका पैसा, and or price, not cost, price, and X is basically food, whatever. We need to show that this is compact if and only if this. So if part says कि if P vector dominates 0, then f of w comma p is compact. I won't write the entire proof क्योंकि थोड़ा सा trivial है. So how do you show this? F is compact. Well, for this, to show this, you need two things. F is bounded and closed, right? So first we show closed. We can take xn converging to x star, let's say yn converging to y star, say, then pxn and xn, pxn is always wait just a sec, we need to show that this is closed, right? So now if we have ki pxn is always less than or equals to w times h minus l, then if you take limits on both sides, that would also be, so यहाँ पर it, so limit n tends to infinity, right? H minus l, and this is basically p times limit of xn. I can take p out, and limit of xn is just, let's say, x star, which is again less than or equals to, this is a constant sequence, so it is just w times h minus l, which implies p times x star belongs to f, right? Now this particular line, this follows from the fact that if an is less than or equals to some an converges to a star, then a star is less than or equals to a. So this result of real analysis we are using. So this result is very important, continuously use हो रहा है. So using that we can say this. ठीक है. तो similarly you can prove for y also. अच्छा y तो था नहीं, l था, sorry. So एक second. Did I admit him? Huh. Where did it go? Right. So right, okay, so one problem is this, sorry, I kind of skipped it. Right, so I have this, just saying this won't work because w is h minus l, right? Now l is always positive, right? So l is always positive. So I cannot just say कि this is will be less than w जो पहले लिखे थे, because l itself is a choice variable. So I kind of need to remove it, but that is easy because l तो यहाँ से minus हो रहा है and l is, so this is always less than or equals to w times h, right? So now we can just use this. Can we? oh sorry, I'm ये bounded बोल रहे हैं, sorry. This we can do, okay, this is correct. To show boundedness of this, we can say that Pn xn is less than or equals to W times H minus L, right, which implies not Pn, P is a constant, Pxn is always less than or equals to W times H, which implies xn is less than or equals to W times H by P, right, and this can be done because P is this, strictly greater than 0, hence it is bounded, and the limit point belongs to the set F. Similarly, we can like similarly it is easy to show that similarly we can show this for any ln converging to L star, say. So that is also that is very very trivial, right? So it is very हाँ यहाँ से just take sequence of ln, each ln is less than or equals to h, therefore limit of ln will be less than or equals to h, that is L star is less than or equals to h, hence L star belongs to this set. So that is easy, hence we will be able to show कि it is both of them are closed, both of them are bounded, hence the entire set is compact. Only if part, how do you show only if part? To show the only if part, it is easier, right? So assume that, so only if part is basically ki if F is compact, then P is strictly greater than 0. Now to show this, we use contradiction. So by way of contradiction, assume F is compact and P is not strictly greater than 0. इसका मतलब होता है there exists some Pi which is less than 0, right? So P is a vector, right? So where P1 is the price of commodity 1, P2 is price of commodity 2, and so on. So what I am saying ki there exists at least one price such that it is negative. Now I can say that this thing P dot product with x, which is essentially summation of Pi xi, this I can write this or let us say Pj xj, right? So j goes from 1 to n for n commodities. I can kind of write it as, let us say, j going from 1 to n, j is not equals to I, Pj xj plus Pi xi, right? So right, so I don't know anything about this, ये क्या है क्यों है, but I know that this Pi is negative. So by choosing a big enough Pi or a big enough mod of Pi, right? So Pi is negative. So let's say Pi is negative something, right? Now if I make, and I can take a absolute value of Pi, ठीक है, or not, okay, sorry, not pi. Now take a big enough xi, right. So let's say pi is -1. Now since I can choose any amount of xi, right, so such that it is less than this quantity. So I can pick a very big xi, this will make the entire thing go to -infinity, right. So by choosing a big enough xi, we can make p dot x as small as possible, which would imply that f of x comma p is not bounded below. Hence, or which implies that f of x comma p is not compact, and hence we arrive at a contradiction. So no need to write hence, contradiction.
f of w comma p, right?
Oh right, sorry. So I hope the logic is clear, right. So basically I can make this as small as possible, and since यहाँ पर हमको बोला था कि it should be less than this, all those x, all those, oh right, so all those thing, yeah, so all those x such that p dot product x is less than this are permissible. If p is negative, then I can so let's say so basically it means that the price of, suppose there are two goods, chocolates and milk, and the price of chocolate is, let's say, -1. That means you will get 1 rupees if you buy a chocolate. So you will just buy unlimited amount of chocolate, and which will make the budget set unbounded below, or unbounded, right. But that is a contradiction, because we assume that our budget set is compact, which implies that it is also bounded. So we arrive at a contradiction. Therefore p must be strictly greater than 0, right. So right, so that is how you show the only if part. 10, 11 I have not done. 13, question number 13 sir has done, therefore I am not going to do it. Then you have question number 14. This is the last question, I guess, because question number 15 again sir has discussed, right. So right, question number 14 is also not that difficult. So a consumer who lives for 2 time periods has utility function this and this. So your utility function is the amount that you are consuming in period 1 and the amount that you are consuming in period 2. Denotes the consumer function this that, ठीक है, where CT वो पढ़ लेना, those context is irrelevant. The price vector at PT, so the price at time period t is given by PT, right. So P1 is basically price vector at time period 1, P2 is price vector at time period 2, and so on. We are only considering 2 time periods, and any amount not spent in the first period can be saved, used for the second period. Savings earn an interest of, so interest rate is interest rate is 1 plus r. It is just r. Interest rate is r. We are asked that assume non-negativity constraints on consumption. So we can assume this. and set up the consumer's utility maximization problem, right? So यहाँ पर I mean I guess almost all of you have come across this intertemporal choice, like plain and simple it is that question. So we need to maximize utility of C1 and C2 such that the budget constraint is satisfied, right? So C1 should be greater than 0, C2 should be greater than or equals to 0, and the third thing that we need is um, the present value of consumption, which is just P1 C1 plus the present value of future consumption, which is P2 C2 divided by 1 plus R, right? This should be less than or equals to the present value of all total income, which is W naught C, right? So this is the thing. Now right, so this is question number A. Question number B is something which is very similar to this, we need to show that the budget constraint, let's say I define it like this, C1 C2 belonging to R2 plus such that P1 C1 plus P2 C2 1 plus R 1 plus R is less than or equals to W naught. So this is my budget set. Now to show that B is compact if and only if P is positive. P is positive matlab P1 is also positive, P2 is also positive, right? Again you use the same arguments. If portion, if part is that if B is compact, P is positive, right? So again by contradiction assume Pj is negative, right? Or you can say something else. You can say without loss of generality assume P1 is negative, right, or it is less than or equals to 0. So here basically here there was one case that I did not consider. So that one case was I assume that Pj is strictly less than 0, right? What would happen if Pj is equals to 0? What would go wrong then, right? So I missed that point here. So अगर Pj less than 0 होगा then तो you follow this line of argument. If Pj is equals to 0, you need to consider both the cases. Then what do you do? For that, so I am going to give that argument here. You can use the same argument there also. So without the loss of generality, assume that P1 is less than, so this, right? The argument would be entirely same if you assume that P2 is less than or equals to 0. Doesn't matter. So case 1 would be P1 is less than 0. In that case, we can make P1 C1 plus P2 C2 by 1 plus R as small as possible by picking a big enough C1, right, which would imply the budget set is unbounded, which gives us a contradiction because we assume that it is compact. Hence P1 is greater than 0. I mean, technically I should write greater than or equals to 0 because I show that it can't be less than 0. So it can be anything that is greater than or equals to 0. But allow me that misuse of notation, because I am going to show that why it is also not possible to have P1 equals to 0, right. So let C1 comma C2 let C1 comma C2 belong to my budget set. Then P1 C1 plus P2 C2 by 1 plus R should be less than or equals to W naught, which is my level of wealth at time period. This is, let's say, W1, right. So if I am assuming P1 to be 0 and everything else is positive, right, I can again, so okay, again there are two line of argument here. If let's say if P1 is equals to 0, then again you can choose C1 as big as possible. It won't affect your W1, it won't affect this inequality, right. So you can again pick jitna bada C1 you want to pick, which will again make the entire set unbounded. That is, so I guess you can also use that here also, no issues. But another way to argue this would be, since this is positive, you can say that P1 C1 will again be less than W1, right, because this is positive, we are omitting this. This means that C1 is less than W1 by P1, which is not possible, because P1 is 0, right. So you can't define this. So you can show this, or you can argue this in two ways. A similar argument would hold here also, right. I don't think, now that I think about it, I don't think you need to show this again, matlab P1 equals to 0, because even if P1 is equals to 0, you can apply the same logic ki you can pick as big C1 as you want, because wo free hai, right. So P1 being equals to 0 matlab C1 ka price hi nahi hai, so it's free. So you will, and if your utility is increasing in C1, you will just pick whatever C that you can get your hands on. Jitna bada ho sake utna bada you will choose, and it will make unbounded. So that is if part. Only if part is again very similar. Ki if P is strictly greater than 0, then my budget set is compact. Use the same argument as before. You use the same argument as this one, right. So since this is less than or equals to 0, you take a sequence C1n and C2n such that they converge to, let's say, C1 star, C2 star, right. And since C1n P1 plus C2n P2 by 1 plus R is less than or equals to W1 or not, I just write it as W naught because हम हर जगह W naught लिखे हैं, doesn't really matter, right. So then limit as n tends to infinity of this thing will also be less than or equals to 0. Again, what are we using? We are using this result. Right? Ki if every sequence ka member is less than or equals to A, then An, so the point of convergence is also less than or equals to A. Keep in mind, you cannot use this result if this inequality is strict. Agar less than or equals to I replace by just less than, you cannot use this result. Keep that in mind. So that right? So this would imply that C1 star, C2 star also belongs to my budget set. Hence, it is closed. You prove that this is closed. Now again, so C1 P1 plus C2 P2 by 1 plus R is less than W naught. Your P2 is positive, C2 is positive. बाय द वे यहाँ पर क्वेश्चन में ही बोल देना चाहिए था कि R must also be positive. अच्छा sorry, not here, not here. Here the rate of interest should also be positive, otherwise वो भी एक दिक्कत करेगा. So we'll just assume it given because explicitly बोला नहीं है. Says R is greater than or equals to 0. This entire thing is positive, so I can just write C1 P1 is less than or equals to W naught, which implies C1 is less than or equals to W naught by P1. So C1 का bound मिल गया. Similarly, I can show. So if I just drop this out, I'll just have this. Inequality will still hold, and C2 would be less than or equals to W naught 1 plus R by P2. So I got bounds for both of them. Hence, the budget set is bounded. Right. So question number 14 and question number 10 was same, almost the same. Question number 13, since sir has done, I am not doing it again. Question number 11, 12 आता नहीं है. And question number 4 में थोड़ा I was 4 and 7, sorry 4 and 6. उधर पे थोड़ा दिक्कत है. So I'll look into it. अगर उसका सही से आंसर मिलता है तो I'll share it with you guys. Any doubts? That kind of ends it.
क्वेश्चन नंबर 8 के अंदर जो हमने वो 10 वाला कांस्टेंट लिया है E बार बाय पी एक्स एंड E बार बाय पी वाई के